Have you ever stopped to think about how people did, really complex calculations before we all had calculators and computers? Well, today we're going to pull back the curtain on this amazing mathematical trick that your grandparents probably knew. We're going to see exactly how they turned ridiculously hard multiplication into simple addition. First things first, let's just take a second and imagine a world without that little device in your pocket. No smartphones, no computers, not even one of those basic pocket calculators. Nope. Everything had to be done by hand. Just you, a pen, and some paper. All right? So, how would you actually go about solving a problem like this one? 58.4 times 9.67. I mean, sure, you could try long multiplication, right? But it's so slow, it's tedious, and let's be honest, it is incredibly easy to make one tiny mistake that just throws the whole answer off. And you gotta remember, for centuries, this wasn't just some boring classroom exercise. For scientists who are mapping the stars or engineers building massive bridges, getting these calculations wrong, that could have absolutely disastrous consequences. They needed a way to do this that was both fast and reliable. And that method, that elegant little secret weapon that they used, was the logarithm. Now, I know it sounds super complicated, but the idea behind it is actually, well, it's beautifully simple. So, what in the world is a logarithm? The easiest way to think about it is like a secret code. Every single number has its own special log code. And the secret is that these codes have this kind of magical property that makes really difficult math incredibly simple. And here it is. This is the real magic. Using these log codes completely transforms the hard, error-prone job of multiplication into simple, straightforward addition. That's it. You can see right here, this simple switch was a total game changer. Instead of spending minutes on painstaking multiplication, you could just find the two log codes for your numbers, add them together, and be done in seconds. It was so much faster and way more reliable. So they are probably wondering, how did they find the logarithm of a number without a calculator? Well, they used a special tool that was, for generations, the absolute cornerstone of every science and engineering classroom, the logarithm table. Okay, so finding the log was basically a two-step process. First, you find something called the characteristic, which is just the whole number part of the log. To get it, you put the number in standard form, which is a fancy way of saying you write it as a number between 1 and 10 times a power of 10. So for our number, 58.4, that's just 5.84 times 10 to the power of 1. And that power, that little 1, is our characteristic. Easy enough, right? That's the first piece of our puzzle. Now, for the second part, the decimal part, this is called the mantissa. And this is where that log table comes in. You'd literally just look down the main column for your first two digits, 58, then slide your finger across that row to the next digit, 4. The number where they meet, that's your mantissa. Okay, theory is great and all, but let's actually see this thing in action. Let's jump back to our original problem and solve it exactly the way an engineer in, say, 1950 would have done it. All right, first up is our number 58.4. Let's find its logarithm. So we do our two-step process, right? The characteristic is 1. Then we look up 58 and 4 in our tables to get the mantissa, which is 0.7664. We just stick them together, and the logarithm of 58.4 is 1.7664. Next, we've got 9.67. We're going to do the exact same thing. For this one, the characteristic is 0.0. We look up 96 and 7 in the tables, and we find that the mantissa is 0.9854. So the full logarithm is 0.9854. And here it is, the moment we've been waiting for. The hard part is totally over. We've turned our numbers into these log codes, and now all we have to do is this super simple addition problem. And the sum is 2.7518. Of course, 2.7518 isn't our final answer. It's the log code for our answer. So now we just have to reverse the process. We look up this code in a reverse table or an antilog table to find out what original number it actually represents. And when we do that, boom, we get our answer, 564.7. Now, if you punch the original problem into a calculator, you will see the exact answer is 564.948. So yeah, incredibly close. And for most real-world users back then, This was way more than accurate enough. Now, I know what you might be thinking. That's a really neat history lesson. But why does any of this matter today? Well, it turns out the idea behind logarithms is actually more important now than it's ever been. You see, logarithmic skills are literally all around us, helping us make sense of absolutely huge numbers. Think about the Richter scale for earthquakes, pH levels in chemistry, even decibels for sound. They all use this exact idea. For instance, an earthquake that's in magnitude 7 isn't just a little bit stronger than a 6, it's 10 times stronger. That's a logarithm at work, compressing a massive change into one simple step. And really, that's what logarithms are all about. They are a tool for taming the enormous. They help us squeeze these massive ranges of numbers, from things that are microscopic to things that are astronomical, down into a scale that we can actually wrap our heads around and work with. It really makes you think, doesn't it? This brilliant analog trick was all about taking a super complex problem and finding a much simpler system to solve it, which leads to a pretty cool question. Where else in our modern digital world, from data compression to AI, are we still using that same fundamental idea of simplifying complexity? Definitely something to chew on. Thanks for watching.